Today, we are looking at 1.6 using algebra in statistics. In this course, we will use some basic knowledge from previous courses. We're going to review a few of the necessary algebra skills you will use this year. So first, we're going to use expressions to solve real-world problems. A company has decided they need to cut the hours worked each week by all part-time employees by 5 hours. For each employee, find the new number of hours per week each will be working after the reduction in hours. So Amy starts with 30 hours. So if she's working 30 hours and reduce that by 5, she's now going to be working 25 hours. Bob originally works 20 hours. If we reduce by 5, he is now working 15 hours. Cal worked 25 hours. If I reduce by 5, he's now working 20 hours. David works T hours, so we could say he's going to work T minus 5 hours. A pizza place sells pizzas for $12 each, and it will cost an additional $2 delivery charge for the entire order. Write numerical expressions for the first 3 blank cells, and then write a variable expression for the last cell. So if we order 1 pizza, it's $12 plus the $2 delivery fee, which is $14. For 2 pizzas, we know they're $12 each, so I can do 2 times 12 plus 2, which is $26. For 3 pizzas, 3 times 12 plus 2, this is going to give us $38. And so in general, for P pizzas, I can write P times 12 plus 2, which, is our expression. All right, we're actually going to skip the next page and let's go to page 21. We're going to use fractions to solve real-world problems. And the explanation of this is also in your technology resource. The sum of the proportions equals 1. If an object is made up of 2 or more parts, then the sum of their proportions equals 1. At the City College of New York in fall 2013, the proportions of students who were African American was approximately 1/5. The proportion of students who were Asian Pacific Islander was approximately 1/4. Find the proportion of City College students who had other ethnicities. So I can do 1/5 plus 1/4. And now if I want to add these, you can go to your Desmos Scientific Calculator. And so on here, I can just type in 1 divided by 5 plus 1 divided by 4. And then it tells us our answer is 0.45. If I hit this little button, then it will write it as a fraction. So we see this is 9/20. So again, this is 9/20. And as a reminder, you're going to hit the button that looks like a little fraction on Desmos to change it to a fraction. All right, so we want the proportion of City College students who had other ethnicities. So we want everyone else. So I'm going to do 1 minus 9/20. So I can do 1 minus 9 divided by 20, hit the fraction button, and we see it's 11/20. So let A divided by B be the proportion of the whole. Then the proportion of the remaining, or rest, is 1 minus A over B. The proportions for the orange and blue disc are 1/4 and 1/3. Find the proportion of the disc that is green. So 1/4 plus 1/3. Again, we can do this on Desmos. So we have 1/4 plus, make sure you click out of your fraction, plus 1/3. I see this is 7/12. And then I do 1 minus 7/12. And that's going to give us 5/12. All right, now we need to find the fraction of the circle that is shaded. So I'm going to start counting with the shaded parts. I have 1, 2, 3, 4, 5 parts that are shaded. 6, 7, 8 out of 8 total. So my fraction of the circle that is shaded is 5/8. Okay. A family spends 1/3 of its income for the mortgages and 1/6 of its income for food. What proportion of its income remains? So we can do 1/3 plus 1/6. Again, we can do this in Desmos. 1/3 plus 1/6. It's going to be 1/2. And I want to know how much is remaining. So I'm going to do 1 minus 1/2, which will just be the other half. So 1/2. Okay. Next, it says use percent to solve real world problems. Percent means for every 100. A% equals A over 100. So we get to write each percent as a fraction and then as a decimal number. So I have 86%. This is 86 over 100 or 0.86. 7%, I have 7 over 100 or 0.07. 0.04% is 0.04 over 100 or 0.0004. 12 3/4%, this is 12.75 over 100, which is 0.1275. Now we have to write each decimal number as a fraction and then as a percent. So 0.1 is going to be 1/10 or 10%. 0.05 is 5 over 100 or 5%. 1.23, that's 123 over 100, so that's 123%. And then 0.002 is 2 over 1,000, which is 0.2%. Now it says using the pie graph in example 6, what is the percent of the graph that is shaded green? So if we look back, we had 5/12 was the proportion that was shaded green. So I can do 5/12. Now if I want, on Desmos, I can do 5 divided by 12, which that tells us it as a decimal. So we can write it as 0.417. We can round that. And so then if I wanted to write that as a percent, it would be 41.7%. Using our pie graph in example 7, what percent of the graph is shaded? So this pie graph, we have 5/8 is shaded. So we're going to do the same thing. 5/8, if I write it as a decimal, it's 0.625, which is 62.5%. All right, using proportions in a table to solve real-world problems. So looking at the table, you're going to determine the part you're asked for, then determine the total or whole. The total may have a column of its own, or you may need to add all the columns to find the total. Once you have these pieces of information, we're going to write the ratio as the part over the whole. So during the COVID-19 pandemic, 1,624 adults were surveyed about how closely they'd been following the news about the pandemic. The results follow. So we define the proportion of those surveyed that followed the news very closely. So very closely is this column right here, 724. Out of our total, we see is 1,624. Now, if I want to reduce this, I can reduce this on Desmos. So I can do 724 divided by 1,624. And if I hit the fraction button, it'll reduce us for us. So it's 181 over 406. So those that did not follow the news very closely would be everyone else. So I can do 1 minus 181 divided by 406. And so let's subtract this. 1 minus 181 divided by 406. And we see that's going to be 225 out of 406. Follow the news very closely or somewhat closely. So, very closely, oops, I guess I could have left that highlighted. 724. Somewhat closely is 587. So we're going to add these. 724 plus 587 divided by our total, which is still 1,624. And so let's add these. We have 724 plus 587. And now I'm going to put parentheses around this. So that way, when we divide it, it's going to divide the whole thing by our 1,624. And we can see that's going to be 1,311 over 1,624. Okay, what does the response no opinion mean in this situation? Should those who responded that way be excluded from the study? So in this case, we could say they either didn't understand the question or didn't want to tell us their answer. So either way, we should exclude them. Okay. Moving on, we're going to use real numbers to solve real world problems. So it says not all data we use are positive numbers. We can still perform statistics on data that is both positive and negative. So we want to consider the following daily low temperature data from Minocqua, Wisconsin. So we want to find the average daily low temperature for the week. So if we want to find the average, we can add all of these up and then divide by the total number. So I'm going to add all of these up. So we have -2 plus 12 plus 9 plus 2 plus 2 plus 9 plus 10. And we can see that's 42. So I can, whoops. Take that away, sorry. So that's 42 for us. And I want to divide by the total. There's 7 of those total. So 42 divided by 7, we can see is 6. So it's 6 degrees. Looking at averages is a common way we look at data. We will now be interested in how far the data points are away from their average. So the deviation of a data point is the difference between the data point and the average of the data set. This difference may be positive if the data point is above the average. It may be negative if the data point is below the average. The deviations tell us how far and in what direction the data point is from the average. So we want to compute the deviation and record in the table above. So again, our deviation is the data point minus the average. Okay, so for this first one, I have -2 minus 6, which is -8. 12 minus 6, which is 6. 9 minus 6 is 3. 2 minus 6 is -4. 2 minus 6, again, is -4. 9 minus 6 is 3. And 10 minus 6 is 4. Compute the sum of the deviations from the table. Are you surprised by the answer? So let's add all of these up. So we have -8 plus 6 plus 3 minus 4 minus 4 plus 3 plus 4. And so we get a sum of 0. And no, this should not be surprising because the average was in the middle. So you have the same number above and below it. Which would end up giving you the sum of 0. Deviation is finding the change in a quantity. So the change in the quantity is the ending amount minus the beginning amount. So if the ending amount is bigger than the beginning amount, the change in quantity is positive. If the ending amount is smaller than the beginning amount, the change in quantity is negative. Okay, using ratios to solve real-world problems. A ratio is used to compare two quantities. For this class, we'll write the comparison as a fraction. A unit ratio is a ratio that is written so the denominator is 1. When we divide a fraction's numerator by its denominator, we get a decimal. This is the unit ratio because technically this means the denominator is 1. This is a clumsy way to write a decimal, so we drop the 1. So a 5-ounce bag of gummy bears is $1.49 and a 144-ounce bag sells for $15.99. Which is the better deal? So first we have to find the unit rate for the 5-ounce bag. So I'm going to do 1.49 divided by 5. So 1.49 divided by 5 is 0.298. So that's 0.298 per ounce. So if we rounded that, that'd be about 30 cents per ounce. What's the unit rate for the 144-ounce bag? Well, this is $15.99 divided by 144. So 15.99 divided by 144. And that is 0.111 if we round. 0.111 per ounce. So again, that's about 11 cents per ounce. So which is the better deal? The 144 ounce, because it is cheaper per ounce. Okay, so to use a proportion is a statement showing two ratios are equal. So you have your percent over 100 equals the part over the whole. So this is an example. A person buys a Fender American Standard Jazz bass for $1,500 at Guitar Center in Indianapolis, Indiana, which has a sales tax of 7%. How much money is the sales tax? So we're going to solve using the cross product. 7 over 100 equals x divided by 1,500. So we cross multiply. So we're going to multiply these two together. 7 times 1,500 equals our x times 100. So we get 10,500 equals 100x. We divide by 100 and we get x equals 105. So sales tax is $105. So 100% of a quantity is all of the quantity. Keep that in mind. All right, Juan answered 34 questions correctly on his chemistry test. He received an 85% on his test. How many total questions were on this chemistry test? Round your answer to the nearest whole number if necessary. So 34 is our part. We're solving for our whole. Equals, he had 85% out of the 100. So if we cross multiply, I'm going to multiply 34 times 100 and x times 85. So that 34 times 100 will give me 3,400 equals 85x. So then we're going to divide both sides by 85. So I'm going to do 3,400 divided by 85, which you can see is 40. Our next one, in a particular condo, there are 12 homes that have children. If there are a total of 40 homes in the condo, what percentage of homes have children? Round your answer to the nearest whole number if necessary. So 12 out of the 40 have children equals x over 100. So again, we're going to cross multiply 40 times x and 12 times 100. So we have 1,200 equals 40x. Divide by 40. So I have 1,200 divided by 40, which is 30. So I get x equals 30, and here we were solving for the percent. All right, use exponents and square roots to solve real-world problems. So make sure we follow the order of operations. Perform operations with parentheses or other grouping symbols starting with the innermost group. Perform exponentiations or exponents, then multiplication division going from left to right, and then addition and subtraction going from left to right. You may have seen this word, PEMDAS. So PEMDAS as a way to remember that. So let's calculate these. So we have 4 to the third power. So if we want to do these in our calculator, I can do 4, and then I hit this button, the A to the B power, and then I can type in 3. So 4 cubed is 64. I have negative 2 to the 5th power, so I'm going to type this just as is. So I have negative 2 to the 5th power. We can see that's negative 32. Then I have negative 2 in parentheses to the 5th power. Let's try that. So I have parentheses, negative 2, close the parentheses, to the 5th power, which is also negative 32. I have 3/4 to the 3rd power. So here, put my parentheses, 3 divided by 4, close the parentheses, raised to the 3rd power, hit the fraction button. I can see it's 27 over 64. Okay, I have 2/5 to the 0 power. So this one, you should get 1. 3 to the negative 2nd power. When you type this one in, I'll show you one with the negative exponent. So if you have 3 to the negative 2nd power, hit your fraction. We see it's 1/9. Our next one, 10 to the negative 4th power, you're going to get 1 over 10,000. Okay, so doing some more algebra. I'll show you a couple of these on the calculator. So our first one, I have 3 times the square root of 2 plus 14. So we can do this in the calculator. I'm going to show you by hand as well. If I add this using order of operations, 2 plus 14 here we're going to do first. So this is 3 times the square root of 16. Square root of 16 is 4, so 3 times 4, which is going to give us 12. Okay, now you can do this in the calculator here. I can do 3 times the square root of 2 plus 14, and you'll see that also shows us it is 12. Our next one, so we have 3 plus our exponent to the third power will give us 8, plus 4 times 5 is going to give us 20. If I add these together, that gives us 31. When we have a fraction like this, we want to simplify the numerator and denominator first, then divide. So 11 minus 3 gives us 8. 1 minus 5 is negative 4. 8 divided by negative 4 gives us negative 2. Here's our next one. We have 2 minus. We're going to do the innermost parentheses first. So I have 7 plus 4 times 3 minus 5 is negative 2. Then 2 minus 7, and then 4 times negative 2 is going to give us negative 8. 7 minus 8 is going to give us negative 1. So I have 2 minus negative 1, which is 3. This next one, we're going to do each parentheses and then the exponent together. So 3.8 minus 6.5 squared, that gives me 7.29, plus 8.6 minus 6.5 squared is going to give us 4.41. 7.1 minus 6.5 squared is going to give us 0.36. Divided by 3 minus 1 is 2. If I add each of these up, that's going to give me the square root of 12.06 divided by 2, which is the square root of 6.03, which is 2.46. All right, this next one, we're evaluating y2 minus y1 over x2 minus x1. You might remember that as a slope formula. So y2 is 4 minus y1 is negative 2 divided by x2, which is negative 5, minus x1, which is 4. So 4 minus negative 2 is 6. Negative 5 minus 4 is negative 9. This will reduce to negative 2/3. Our next one, we have x bar minus t times s divided by square root of n. So our x bar is 30 minus our t is 2 times s is 12 divided by square root of 16. So this is 30 minus 2 times 12 divided by 4. Well, 12 divided by 4 is 3. So this is 30 minus 2 times 3. Then we multiply. 30 minus 6, which is 24. The attendance at Broadway shows was 12.3 million people in 2009, and it decreased by 2.9% in 2010. What was the attendance in 2010? So I have 2.9%, so that's out of 100, equals x divided by 12.3. So we're going to cross multiply 100 times x and 2.9 times 12.3. So we have 2.9 times 12.3, which is going to give us 12, oops, I'm sorry. That gives us 35.67, which is equal to 100x. Then we divide by 100, and I get x is equal to 0.3567. And that's how much it decreased by. So I'm going to do 12.3 minus 0.3567, which is 11.9433, and these units are million. So we're talking about millions of people. All right, our last problem for today, find the area of the orange bar. The entire object is 1. The object is not drawn to scale. So if I want to find the area of the smaller blue one, so this first one, remember, area of a rectangle is base times height. So I can do 0.06 times 2, and that's going to give me 0.12. Okay, then for the remaining blue ones, I have 0.09 times 2, and so that's going to give me 0.18. So this is 0.18, 0.18, 0.18. We know the entire object is 1, so I can do 1 minus 0.12 minus 0.18 minus 0.18 minus 0.18, because there's 3 of those. And if I subtract that, that's going to give me 0.34. So the area of the orange box will be 0.34. And that is where we will stop today.